today we're going to start chapter 6. Everybody should have a yellow sheet, the syllabus, and should have a blue sheet with all the information you need for chapter 6. Tonight's homework is exactly what's on the sheet. The homework exercise from 16 to 31 odd you should do by hand and graph them on a piece of graph paper. There is graph paper on the internet if you don't have it. The 33 through 43 odd, I'm going to let you do with a calculator. I'll show you how to do that with a calculator, and put together a chart and table and plug the information in and graph those with the calculator. Like I said, today we're going to be talking about parabolas. Up here I have a picture of McDonald's arch, which I'm not sure McDonald's has any arches anymore, but nevertheless, they used to have arches at all of their McDonald's. That arch is a parabola. In this case, it faces down, and it has a maximum value, which obviously is at the top of the arch. When we talk about quadratic equations, if they're in the form, or functions, if they're in the form of y is equal to ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0. So quadratic functions face up or down. The quadratic term is the term that has a square, so it's ax squared. If a is a positive number, your parabola will face up. Will have a minimum value. If a is a negative number, it will face down and have a maximum value. As the absolute value of a increases, meaning gets to be a larger number, like 2, 4, 6, 8, your curve gets skinnier or narrower. As the absolute value of a decreases, meaning 1/2, 1/8, 1/16, the curve gets flatter or wider. Linear term dx is kind of like this. It has the effect of shifting the parabola left or right. C is a constant term. It has the effect of shifting the curve up or down. The axis of symmetry is a line about which the parabola is symmetric. The equation for the axis of symmetry is x equals to negative b over 2a. is the point of intersection of the parabola and axis of symmetry. The vertex is either the maximum or minimum value of the curve. The vertex is a point on the parabola and a point on the axis of symmetry. So it has an x and y coordinate. X coordinate is negative b over 2a, and the y coordinate is f of negative b over 2a. We'll talk about that later. Scary, but it's not. Y-intercept, 0 and c, is where the curve crosses the y-axis, or intersects the y-axis. The x-intercepts are where the curve crosses the x-axis. To find the x-intercepts, we're going to factor. We will not be finding the x-intercepts tonight. Before I start, I just want to review a topic that is something that all y'all probably remember. Remember, we started talking about functions in about chapter 2. And we had something like f of x equal to 2x plus 5. That is in function notation form. I said if that was confusing, you could rewrite this as y is equal to 2x plus 5. And then we were given a problem like f of 5. We were asked to find that. This is y is equal to 2 times 5 plus 5. So we would have found that y was equal to 16. So, having reviewed that, what does all this mean? Well, that says negative b over 2a. That's the x value. And what is this telling you to do? Find the y value. Say that louder. What that's asking you to do is take negative b over 2a and plug it in the function to find y. So the first example I have is the easiest parabola there is. I'll give you a minute to get it on your paper. Y is equal to x squared. This is in the form of y is equal to x squared plus 0x plus 0. What is a? A is equal to 1. B is equal to 0. And C is equal to 0. On tonight's homework, I expect you to find A, B, and C, and then to find all of these things what we have listed here. The axis of symmetry equation is x equal to negative b over 2a. So in this case, we have x equals 0 over 2 times 1. So we get x is equal to 0. X is equal to some number is a vertical line, so it is a vertical line on the y-axis. The vertex, all of that mumbo jumbo that was on the vertex information is asking you to take what you got, 0, plug it in the function. Plug it in, get 0. The vertex is at 0, 0. The vertex is always on the axis of symmetry. If your vertex is not on the axis of symmetry, you did something wrong. The axis of symmetry should be a dotted line. The y-intercept is 0 for B. So in this case, the y-intercept is also 0, 0. So the vertex and the y-intercept are the same. That's not always the case, but in this one it is. Next, you need to make a table. You need to choose some numbers to the right. From the axis of symmetry and some numbers to the left. You know the vertex is 0, 0. So I'm going to choose 1 and 2. And negative 1 and negative 2. We will plug them into the function. So we're plugging 1 in the function. And we get 1. We plug in 2, we get 4. Plug in negative 1, we get negative 2, we get 4. We have 1 and 1, we have 2 and 4. Negative 1 and 1, negative 2 and 4. So does it have a minimum value or a maximum value? Minimum value. When A is a positive number, it will have a minimum value. Now we need to talk about the domain difference. The domain is made up of all the x values. So what's the domain? All real numbers. The range is made up of all the y values. Y such that y is greater than or equal to 0. The y value of the vertex will either be the maximum value or the minimum value of the curve. Everybody okay? The next example says f of x is equal to x squared minus 2x minus 3. So does the curve face up or down? It faces up because a is a positive number. Once again, we need to find a, 1, b is equal to negative 2, and c is equal to negative 3. The axis of symmetry is x equals negative b over 2a. So x is negative of a negative 2 over 2 times 1. So x is equal to 1. We have an axis of symmetry on x is equal to 1. find the vertex, you're going to take, after you found for the axis of symmetry, which is 1, you're going to plug it in the function. So we go back up here and we plug it in the function. We get 1 squared minus 2 times 1 minus 3. We get 1 minus 5, so we get negative 4. The y value of the vertex is negative 4. So we're at 1 and negative 4. Y-intercept is 0, 2. That's 0, negative 3. We have a point right here. At the vertex is 1 and negative 4. We have the y-intercept 0 and negative 3. We need to choose some more points. It is an axis of symmetry. That means the distance from here to here is the same in the other direction. So that point is 2 and negative 3. If we choose another number, perhaps 3, we plug it in the function, we get y is equal to 3 squared minus 2 times 3 minus 3. So we get 9 minus 9, or y is equal to 0. Once again, the distance from here to here is the same in the other direction, so we can put a point right there. The domain is made up of all real numbers in range. Y such that y is greater than or equal to negative 4. How y'all doing? The vertex takes what you found for the axis of symmetry, which is x is equal to 1. Plug it in the function, and you'll get the y value. Everybody okay? This is problem number 25 on tonight's homework. Does the curve face up or down? It faces down because a is a negative number. So it has a maximum value. Maximum or minimum value of a parabola that faces up or down is always the y value of the vertex. So we have that a is equal to negative 1, we have b is equal to 8, and we have c is equal to negative 3. We're looking for the axis of symmetry. It is x is equal to negative b over 2 times a, which is negative 2. So x is equal to 2. plus 8 times 2 times 3. We get y is equal to 5. The y-intercept is 0 and c, so it is 0 and negative 3. So we know the distance from here to here is the same in the other direction. So we have 4 and negative 20. We probably need to put in another number, so we'll plug in 3. And plug in 3, what do we get? We'll get y is equal to 3. The domain is all real numbers. The range is y, such that y is less than or equal to 5. Everybody okay with that? The next one I would like to do with a calculator, so if you have a calculator, you need to get it out. If you don't have a calculator, I have a couple of them here. For the last problems on tonight's homework, I want you to use your calculator. This is problem number 35 on tonight's homework. A is equal to 1, B is equal to 6, and C is equal to negative 2. So before we start, let's look at your calculator and make sure everybody is in the same place. So I'm going to go to Zoom and choose 6 or Z standard. And I'm going to go to Y equals. Plug in the function xt theta squared plus 6x minus 2. When you graph it, you notice you don't get the bottom of the curve. So let's talk about how we're going to change it. change the minimum y value to negative 15. And when I graph it, you see I get the bell curve. Does it have a minimum value or a maximum value? It has a minimum value. So if you go to Edit, Calculate, or Trace, you'll notice up here I have value 0, minimum, maximum, intersection. Obviously I want a minimum value, so I would choose the minimum value. And you'll see I have a little blinking bug up here. And I want to move it to the left side of the vertex because it says left boundary. So I'll hit this button until the blinking bug gets on the other side of the vertex. When it's on the other side of the vertex, I'm going to hit enter. And it says right boundary, so I want the blinking bug on the right side of the vertex. Once it's there, I'm going to hit enter. Some of you, if you have a new operating system, it won't ask you to guess it. It would just go ahead and give it to you. But on my operating system, it wants me to guess, so I have to hit enter again. And I get a minimum value at negative 3, negative 11. So I know that x is equal to negative 3 is the vertex. I'm sorry, axis of symmetry. The vertex is negative 3, negative 11. So you can plot those points and draw the axis of symmetry, right? Now let's look at the table. Obviously, we can pick out the y-intercept. It would be 0, negative 2. If we wanted to look at the table, we would hit second, graph the table, and you see where I have a table. You can plot these points. Now let's go with these points. I'm going to hit second quit. Go to program. Plot. When plot form comes up, if you hit enter, it asks you for A, B, and C. A is equal to 1. Enter. B is equal to 6. Enter. C is equal to negative 2. Enter. It gives you the discriminant, which we'll talk about later, the roots. In this case, are irrational numbers. They are where the curve crosses the x-axis. But if you hit continue, you'll find that the axis symmetry of x is equal to negative 3, and the vertex is negative 3 and negative 11. That means we have no problem. the graph